Chemical bonds are what is responsible for connecting atoms together to form compounds, which are all around us, from the air we breathe to the food we eat. So what exactly are those bonds? In this video, we will go over why atoms form bonds in the first place, and the three main types of strong chemical bonds, the ionic, polar and nonpolar covalent, and metallic bonds. So why do atoms want to bond in the first place? That is because every atom wants to achieve their most stable and least reactive state, just like the noble gases. In order to achieve this, atoms have to fill up their outermost shell with electrons. So in other words, their valence shell has to be full of electrons in order to become their most stable state. They will try to either lose or gain electrons in the case of ionic bonds, share electrons in the case of covalent bonds, or form a sea of electrons in the case of metallic bonds. Starting off with ionic bonds, they are the bonds you see between metals and non-metals, with the classic example being table salt, or sodium chloride. The sodium is the metal, while the chlorine is the non-metal. In an ionic bond, the metal will want to get rid of its electrons, while the non-metal will gladly take the electrons, which converts both atoms in an ionic bond into ions. An ion is essentially an atom that is missing electrons, making it positively charged in a cation, or an atom that has extra electrons, making it negatively charged in an anion. So in the case of sodium chloride, the sodium gets rid of its extra electrons to become stable in a cation, while the chloride receives this electron to become stable in an anion, while bonding together in the process. Furthermore, if you drop an ionic compound into water, they will usually all dissolve, meaning that the ions of both atoms will break apart as they form bonds with the water molecules instead. A compound formed this way is referred to as, well, an ionic compound, not as a molecule. So you can never have a molecule of sodium chloride, as molecules only refer to compounds formed by covalent bonds, which are the bonds you see between two nonmetals, with the classic example being the water molecule, or H2O, and this is a bond that is most essential for life. In a covalent bond, instead of giving away electrons, the nonmetals actually share their electrons to become stable. In the case of the water molecule, the two hydrogen atoms combine themselves with the oxygen atom by making sure the oxygen has 8 electrons to become stable, while the hydrogens have 2 electrons to become stable. There are two types of covalent bonds, polar and nonpolar. Polar covalent bonds are formed if some atoms in the bond are a lot more electronegative than the other atoms, causing more electrons to veer towards one end of the molecule. In general, the more upper right you go on a periodic table, the more electronegative an element is, with fluorine being the most. So in the case of water, oxygen is much more electronegative than the hydrogen, so most of the shared electrons actually prefer to hang around the oxygen atom rather than the hydrogen atoms, making the oxygen end slightly more negative and the hydrogen end slightly more positive, making the water molecule polar. A nonpolar covalent bond is generally formed between atoms of similar electronegativity, or usually between two of the same atoms. In the case of oxygen gas, since oxygen is a nonmetal, and two oxygen atoms will have the same electronegativity, the shared electrons don't have a bias towards any particular oxygen atom, making this molecule nonpolar. Lastly, we have metallic bonds, which are the bonds formed between two metals in the case of, say, a big chunk of potassium. A potassium atom can't exactly share electrons with or give an electron to another potassium atom. So instead, they have what we call a sea of electrons, or a valence band, without becoming ions. This is essentially when all the metal atoms have overlapping valence electrons as they flow throughout all of the metal atoms, forming the metallic bonds. This is also why metals are so good at conducting electricity, as electrons are already easily flowing through the metal compounds through the sea of electrons. Those compounds are just referred to as metals or alloys. And there we have it, the three different types of strong chemical bonds. Ionic compounds have ionic bonds between metals and nonmetals that lose or gain electrons between atoms. Molecules have covalent bonds between nonmetals that share electrons between the atoms. And metal and alloys have metallic bonds between metals that have sea of electrons that have electrons flowing throughout the atoms. I hope that y'all have learned something interesting today. Thank you for watching, and good luck with everything!